Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.11. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.11. Find the value of current I0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this 2 kilo ohm resistance labeled as I0. So without wasting time, let's proceed towards the solution. First of all, if we observe, there is a voltage source inside this network that exists between two non-reference nodes. So this problem cannot be solved using simple nodal analysis technique. In order to solve this problem, we have to adopt super node analysis technique. Before applying supernode analysis technique, first we have to learn the concept of supernode analysis. If you already know its concept, you may skip this part of the video. Here I am taking a reference circuit diagram for the understanding of supernode analysis concept. In order to apply supernode analysis technique, we have to remember a solid key point. If a voltage source exists between two non-reference nodes, then supernode analysis technique will be applied to solve that problem. And in order to apply supernode analysis technique, we have to merge that voltage source to any one of its adjacent node voltages. Whenever we will merge voltage source to its adjacent any node voltage, that node will act as supernode. Now we will learn about how the voltage source is merged to its corresponding node voltage. For better understanding, we will take this part of the circuit in order to form a supernode. Here a 12 volt source exists between two non-reference nodes. Now as we are dealing in simple nodal analysis technique, voltage across any element between two nodes is always equal to the difference of those two node voltages. In this case, voltage across this voltage source is 12 volt, which is indicating that the potential difference of these two node voltages is 12 volt. So we can write this statement in mathematical form. Potential difference of these two node voltages is equal to 12 volt. We will consider both cases, and in both cases the voltage equations will be same. In first case, we are considering voltage V2 is on higher potential than voltage V3. So the direction of current will be from V2 to V3. V2 minus V3 will be equal to minus 12 volt. Here the direction of current is from this node to this node and current is entering from negative terminal. That's why this 12 volt is taken with negative sign. Now if we want to merge the value of this voltage source towards this node V2, then using this equation, the equation of voltage for V2 will be equal to V3 minus 12 volt. Similarly, if we want to merge this voltage source towards V3, so using this equation again, the equation for this node voltage V3 will be equal to V2 plus 12 volt. Now we will consider another case where voltage on V3 is on higher potential than voltage V2. In this case, voltage difference between these two node voltages will be equal to V3 minus V2 equal to plus 12 volt. Here V3 is on higher potential than V2. It means the direction of current is from V3 to V2 and the current entering terminal is positive. That's why this 12 volt is taken with positive sign. Now using this equation, we can merge this voltage source either to V3 or V2. If we merge the value of this voltage source to node V3, then using this equation V3 will be equal to V2 plus 12 volt. Similarly, if we merge this voltage source into node V2, then V2 using this equation will be equal to V3 minus 12 volt. You may see that in both cases the equations for V3 and V2 are same. After calculating node voltage equations including voltage source value, we can form supernode on these 2 points. In this first diagram, 12 volt source is merged with V3 and V3 is replaced with its equation V2 plus 12 volt. Similarly, in this second diagram, 12 volt source is merged with V2 and V2 is replaced with V3 minus 12 volt. After merging the voltage source to either node, this node will act as supernode and it will be considered a single node inside the network. Now move back towards the problem. So first of all, we have to make a supernode on this point, and in order to make supernode, we have to merge this voltage source to either this node or this node. For the merging of this voltage source to any node, we will write the potential difference equation of these two node voltages. We are considering that V1 is on higher potential than V2. So potential difference between these two nodes will be equal to voltage across this dependent voltage source. And because V1 is on higher potential, it means the direction of current is from V1 to V2. In this case, current is entering from negative terminal of this dependent voltage source. That's why the voltage across this dependent voltage source is taken with negative sign. Now we will merge this voltage source with node voltage V2. In this case, V2 using this equation will be equal to V1 plus 2000 times Ix. So now we can make a supernode inside this network on this point by merging this voltage source with V2 and replacing V2 with this equation. At this point, a supernode is formed and this node will act as a single node for this network. Currents through all branches in this network is already given in this scenario, so we don't have to assume any current. And in this network, only one non-reference node exists, so we will apply Kirchoff's current law on this supernode to find its node voltage equation. On this node, only one current is entering, that is 4 mA, while rest of all other currents are leaving from this node. All leaving currents are taken with negative sign. In next step, we have to replace these currents with their corresponding equations. Current Ix will be equal to V1 divided by 2 kilo ohm because voltage V1 is appearing across this 2 kilo ohm resistance. Similarly, current through this 2 kilo ohm resistance will be equal to voltage across it, that is V1 plus 2000 times Ix divided by the value of resistance. For the solution of this equation, we will multiply this equation on both sides with 2 kilo ohm in order to omit all denominator values. Product of 2 kilo ohm and 4 milliampere will result 8 volt. Kilo will cancel out with milli. Here 2 kilo ohm will cancel out with 2 kilo ohm in denominator, only V1 will left. Product of 2 kilo ohm and 2 milliampere will result 4 volt. Similarly, 2 kilo ohm will cancel out with 2 kilo ohm in denominator, only V1 plus 2000 times Ix will left. Open these brackets, minus will multiply with values inside the brackets. It will become minus V1 and minus 2000 times Ix. Now inside this equation, subtract 4 volt from 8 volt, it will become 4 volt. Minus V1 and minus V1 will become 2V1. And here Ix is replaced with its value, that is V1 divided by 2 kilo ohm. Now this 2000 will cancel out with the product of 2000. The equation will become minus 2V1 plus 4 volt minus V1 equal to 0. Add minus V1 and minus 2V1, it will become minus 3V1 and place it on the other hand side of equal to make it positive. Now in order to calculate the value of voltage V1, we will divide on both sides with 3. The value of voltage V1 will become 1.33 volt. After calculating the value of voltage V1, we are able to calculate the value of current Ix, and later on this node voltage, that is V1 plus 2000 times Ix. And if we succeed to calculate this node voltage, we will be able to calculate current through this 2 kilo ohm resistance that we are required to calculate in this scenario. So first of all, we will find this current Ix using Ohm's law. Ix will be equal to V1 divided by 2 kilo ohm. Value of V1 is 1.33 volt. So the value of current Ix will become 0.67 milliampere. After calculating the value of current, now we are able to calculate this node voltage by replacing the value of current Ix and V. After calculating the value of current Ix, we are able to calculate this node voltage by replacing current Ix and V1 with their respective values. This node voltage is equal to V1 plus 2000 times Ix. Replace V1 and Ix with their values and solve this equation. The value of this super node voltage will be 2.67 volt. After calculating this node voltage, that is 2.67 volt, we are able to calculate current through this 2 kilo ohm resistance using Ohm's law. I0 will be equal to 2.67 volt divided by 2 kilo ohm. So the value of current I0 inside this network will be equal to 1.33 milliampere. So this was chapter 3 learning assessment E3.11. Thank you. See you again in next video.